Hey, good morning. So today I'm going to be doing more coding on my project. Stream looks good. I'm going to put this down here so I don't miss any chats. Um, okay, so here's what I'm going to be working on today. Well, we'll just go here. I just wrote it in the description for this stream. So yesterday I did 3 streams. I really only meant to do two, a morning and afternoon stream, but Um, the there was something wrong with my internet and the afternoon stream cut partway through. But what I was able to do yesterday is generalize the region definition so that we can easily add a new region. Um, when I was doing that yesterday, I went through and put a bunch of notes here for things we need to do. Um, I wrote done as I completed each of them. Um, but yeah, so these were all the changes we had to make so that the um, this code was generalized to work for any region. And then on top of that, that's just what I wrote down to do. I still had some errors. So now when we're entering a region in here, all we have to do is add it to the valid region types dictionary, and the key for the dictionary should be whatever the name of the region is we're calling it. And then the value should be a list of um, the value should be a list of the parameters that are passed in for this region. Um, so the first one I'm making is a free circle. I'm going to also add another region called free triangle. So a free circle, all you need is the center point, X and Y, and then you need a radius. A free triangle gets considerably more complicated because um, you have 3 points. So there's point 1x, point 1y, point 2x, point 2y, oops, um, point 3x, and then point 3y. Okay, so that's what we want for the triangle. So you could see why I'm doing the circle first. My initial idea was to do a free square, but that's going to be a bit harder. So we could just do a free triangle as the first thing, but the circle is half the number of parameters, so obviously we want to do the circle first. So back to what I was saying is now if you want to, before to add a new region, we had to do all this stuff. Now if you want to add a new region, you just write it into valid region types as I just did. Now for inside of test region type, you should write this in, but you don't have to. Um, or I is really what I'm talking about. Um, so yeah, this just helps me figure out what the regions are. And then this just says if region type not invalid region types dot keys. So really all we need to add so far is this. And it's nice to add this description, but I don't need it. But I'm putting it in so I know what each region does. And then inside of get region, all we need to add is another elif loop. Elif region type equals whatever our region is. And that's it. We don't need to worry about anything else. So right now I'm defining the free circle region. Now the center point is defined as region params of H, comma, region params of K. Okay. And then radius is equal to region, it doesn't need to be a tuple, it could just be a value. So radius equals region params of uh, oops, this I don't want to be so big. We're just looking at that description. We don't need to see it for too long. Okay, so, um, okay, so we have a center point, then we have the radius. R, I think, is just what I called that. Yep. Okay, now let's figure out how to make a circle in Shapely. Circle equals 0.55. So could we just add a buffer around the point? We also might want to do free ellipse. Look into, so we want to look into doing a free ellipse region. Okay, and we'll make that high priority because that's what I want to do today. Or I want to do that today. Um, Add in random box region to optimize for, gonna do that. And random circle region. Okay. Repeat analysis on all region types. So that we do want to do using total percent return as the value to optimize for instead of profit. I think I may have done that. Let's go see. Well, we could run this either way, so let's just go run that real quick. Okay, so optimize line location. Perform optimization analysis. So let's do, we're gonna test on, oh, let's just do, yeah, let's do 2010 to 2022, and years to train on should be all. And I think I did this for the first region. Let's go look. Or maybe it wasn't the first region. Maybe, well, either way, let's do it with the triangle. Yeah, that's what I did. I did it with the triangle region, but it was the modified triangle region. Um, just say here. All right, so I'm actually going to add another one. Modified triangle. Okay, and then we could say that modified triangle also just has x int. And then here we could say that a modified triangle same as triangle, but contains a second line offset by minus 180. Same as triangle, but contains a second line offset by 180. Same as hybrid with B fixed to minus 180. And then here we could say if region type equals triangle, elif region type is equal to rectangle. So otherwise, if region type is equal to modified triangle, I think that's what I called it, modified triangle, yeah. So if region type is modified triangle, then what we want to do is basically this, but we want to get the points that we've overwritten and are using. So this 0.2 can go away, and then the first 0.3 can go away. And then this one, the second 0.3 can go away. And then the second 0.2 can go away. So now we have our own region for modified triangle. Did I Yep, this is right. So now we have our own region for modified triangle, and we can go back and say perform optimization analysis on the original triangle, because now we're doing percent, now we have percent returns. And then, yeah, we should probably write a metadata file for when we're doing the optimization analysis. So to do that, we're going to want to be able to pass a metadata file into optimize line location. So optimization data slash folder. Okay, and then folder location should be a string. And then by default, it's located inside optimization data. And if we want a different folder location, we have to specify it. Okay, that seems good. Now, let's take out this debugger line because we don't need it. So we pass in the folder location. Now for folder and os.listdir of folder location, optimize data, and this should be folder location. So I guess just now every time we see optimization data, we just have to change that to folder location. That's pretty easy. Folder location, optimization data. Let's just make sure that there's nice. So that actually should be it. File name dot split on the dot, yeah. Okay. So now we could say perform optimizations. Um, metadata file is equal to, um, so we'll also put a folder location in here, just so we could change it if for some reason we want to. And by default, it should be equal to optimization data slash um, slash so it's not a single optimization. So it's a group optimization slash, don't need that second slash. Now this up here, optimization data, should save optimization data slash single optimizations. Um, okay. Now folder location equals that. Um, meta, uh, so let's see. We're indexing by the date. So we're going to want to make a new folder. Perform analysis for each year. Um, so we're going to go to the folder for the date. Has date folder. So this will always increment by whatever the date is. Folder location. I'm trying to think. So we have we've specified a unique folder location, but then inside optimize line location, it so basically what's going to happen here is it's going to say, okay, go optimization data slash single optimizations, then it'll get the date, and then that's exactly what we want it to do for single optimizations. So it does num from this date. Okay, so we're gonna call this um okay, fancy dates that num from has date folder. So for folder and os.listdir, if we have the folder, so we could say if folder location is single optimizations, do this. Otherwise, okay, so if folder location is equal to, so if we want to put it in single optimizations, so if this is our folder location, then do this whole thing. Okay, so then we're making the directory, we getting the file index, file name, and then everything from there is based off of the file name. So do that. else um, num in um, okay, so this actually we're going to say if file name is equal to none, if file name is equal to none, then do that whole thing. If file name is not equal to none, then file name is equal to folder location slash file name. Folder location slash file name dot CSV. So we don't need to add CSV to the file name. Now in here, perform optimizations. We could just pass in a file name now. Okay. Region params equals optimized line location. Training seasons region type equals region type. Folder location is equal to folder location. Let's make this easier to look at. Okay, folder location equals folder location. And then file name. What should the file name be? So optimize line location. Test seasons. So let's just say test seasons of 0. File name is whatever the year is. So blank dot. Okay, so that's good. Now we want metadata. So metadata file is equal to the function string, folder location slash. So don't need that. We could just say with open fstring folder location with open fstring folder location slash. Okay, so now we want to get the date. So let's do the same thing we were doing up here. Nice. Okay, so whoa, that's so optimize line location. If file name is equal to none, okay, so we want this whole thing. And we're gonna have to delete some stuff out of it. Open metadata as f, pass, folder location slash folder. So then we're just gonna increment num by the state by 1, but we want it to be folders, not CSV files. So we take out that part where we're looking for the CSV ending. And then if has date folder is equal to false, then make the date folder. And then num from this date would just be 0. And then file index is equal to num from this date. No. So we want the date folder. Has date folder equals false for OS for folder. Okay, so then we're getting for each subfolder num from this date plus equals 1. And if it doesn't have the date folder, then make it. Then file index. Well, so that's not file index, that's just folder index. And then file name is folder location. Okay, so when we pass in file name here, it should just be a name, not a CSV even or anything. Folder index is equal to num from this date, and then file name equals f of folder location, fancy date, file index. Oh, folder index slash folder index. So folder location slash fancy date slash folder index slash folder index dot CSV. So now we have a folder to put everything in. This is folder name, not file name. Then with open, okay, so that's folder name, file name, metadata file. With open folder name dot split. So we're going to split the folder name on the dot. Oops. Split it on the dot. And then get the 0th index of it. So that's everything except for the .csv. Take that out. Okay, so now we're done. So we take that out. We actually just want folder name slash metadata dot text as f, and then we're going to write all of the parameters that we pass in. So test years, f dot write test years, initialized at date time dot now. All right, so initialize now. Then let's write and then \n metadata, and then another \n. Then write initialized at datetime dot now. Then let's write put another \n initialized at whatever time, test years, f dot write. So we want to say test years and then print our test years. Now we want to write num years to train on. Forgot, we don't, could take that out, make it look nice, don't need underscores. Num years to train on should be num years to train on. Right, a \n, \n. Okay. Um, got number test years, number of years to train on, region type, and folder location. Folder location doesn't matter. Um, okay, so now we have metadata written. Now, when we call the function, we're saying folder location is equal to folder location. Folder location is equal to folder location slash optimizations slash optimizations, but folder location should just be our folder name. Folder name. Folder location is equal to folder name. And then file name should be the season, whatever the season is. All right, now let's make sure that this is running. Perform optimization analysis. Okay. Now let's see what the pop size is. Perform optimization. So we should also be able to specify the pop size, obviously. Pop size int equals 10. So it's going to default to 10. And then need to find where our differential evolution line is. Where's the optimizer? Here we go. Pop size is equal to pop size. And then we're going to add that in perform optimizations. Pop size is an int that defaults to 10. And then when we call this, we're going to say that pop size is equal to pop size. And then we're also going to write it into the metadata file. Population size, and then put pop size in there. Okay. So let's run that and let's see if the metadata is saving. No such directory. Right, we need to make it. Group optimizations. So when we pass in the folder location, we're going to say if it doesn't exist, make it. If os.path.exists of folder location is equal to false, os.makeDirectory of folder location. So if the folder location isn't real, make it. With openf folder name for folder. What line is that? Folder name referenced. Line 373. For folder and os.listdir folder location. Oh, if has date folder is equal to false, then make it. Huh. So for folder, so we're going for each folder in optimization data slash group optimizations. If folder is equal to fancy date, has date folder is equal to true. So if we have the folder, then we're going to look through each subfolder. Okay, so if we have the folder, we're going to look through each subfolder and count, and then we increment number from the state of 1. Um, that's if has date folder is equal to true. I don't think that is true. Obviously, it should be false. Yep, because there's nothing in there. All right. For folder and os.listdir, if has date folder is equal to false, which it is, then make the date folder, and then folder index, then make the date folder. If it doesn't have it, then make it. But this should all be outside of the loop. All right, let's run it again. No such file or directory. So it's 0/metadata.txt. So it should be 0.0. Oh, with open folder name. All right, so folder name. So now we're gonna say os.makedir of folder name, and then we should be good. Optimization data, group optimizations. Took the slash out, but we need the slash in there. No such file or directory. All right, let's go see what the directory looks like. So there's 0 and 1 with open. So this, I think, is because we just need to do a plus so that it's appending and it doesn't try to go find the file. Nice. All right, now let's go see what the metadata looks like. Initialized test use, and I'm used to train on. Oh, damn. And we want to save the results. And each of these should go into its own subfolder. So, folder location, instead of folder name, it should be f of folder name slash this. And then down file name should just be I mean, results, because then the picture will save as the same name. We'll have a picture, you'll have metadata, a picture, results underscore metadata. I mean, it'll be fine. All right, and then all right, and instead of saving there, we want to save want to save it in folder name. Folder name slash results dot CSV. All right. Now this df equals pd dot data frame test years profit. So for year in each. I mean, yeah, why not do this every loop? Results dot append result. Let's do it for every year. And then the other change we're going to make is not say profit, percent return. Okay. Now let's run that. See how it does. Folder name 2010 with open metadata file. A plus is F. 291. Folder name slash O. Oh, duh. But why is it? So I run it and it runs into that problem? Huh. Folder name slash 2010. Analysis 1.py. Oh, it's in optimized line location. Optimize line location. Okay, so metadata file equals file name dot split. So folder name slash 2010 results metadata. There's no, maybe I'm passing in the wrong thing in here. Yes, I am. I am passing in the wrong thing. So let's run it again. See what this returns. Okay. 2023 1214 slash 5 slash 2010. 2023 1214. Okay. Slash 5 slash. Okay, so there's no folder for 2010. Obviously. So we're going to go make a directory for this. Save it. And let's go run it. Okay, so that's looking good. Let's just check real quick. All right, so here's today. So I guess we could go higher. All right, here's our main folder, optimization data, group optimizations. Damn it. Um, Perform optimizations. When we make a data frame, all arrays must be of the same length. Oh, so test years. So test years. Okay. So let's go look at how we want to mess with this in the terminal. So test, let's say import numpy as np. Now test years is equal to np.arange from 2007 to 2022 dot toList. Test years. So for year in test years, here we could say year in year for test years if year is less than, so say it's on for year in test years, so let's say we're on 2008. Year, oh, year for year. Year for year. How did I do that? For test year, so if the year is 2008, then we'll have another profit. So if year is less than or equal to whatever we want. Okay, let's move this over here so we can see it. All right, so now we can say year, instead of test years, it should be year for year in test years if, okay, so let's say I for I, item for item, in test years, if item is less than or equal to year. Okay, let's exit out of there and try running this one more time. Now that works, but it was working before. Now we should hopefully get the results. Weird name for the file. Yeah. Shouldn't get the variable results. It should just be that. All right, now let's exit out of here. Let's just check to make sure results look good. Nice. Okay. Make sure we save that and let's run it again. All right. Now let's go watch in the folder. Make sure it does what we want. If this should be doing what we want, and if it indeed is, we could just leave this and go focus on coding up the region. Nice. Nice. Okay. So it got positive results for the first 2 years. So We're working on that. We've finished editing the metadata file for the plotting analysis. We still have this question to answer. Attempt analysis on analysis 1, trend 3 with higher update rate. That's going to be a ways off because the yearly update rate is a lot easier right now. Try last n week spread as neural net input. That's later. Find more data. That's for later after we're done working on the strategy. ELO ratings is for later. Get data from 538 later. Speed up code later. Get new data set with Rose's bets. That could be good to do. Gonna change that to be medium priority. Okay. And let's make sure that this still looks good. Wow, nice. The triangle one optimizes quickly. Wait, are those all positive? Wow, those are all positive so far. Well, let's keep our fingers crossed and hope 2018 through 2021 stays positive. I'm gonna go to the bathroom real quick. I'll be right back. All right, so the next thing we want to do is code up our different regions. We'll repeat analysis type on all region types. Oh, so it finished. Let's go see how it did. Oh, so positive every year except 2. That's pretty good. That is definitely a significant improvement just using percent returns. So let's put that in our file. So we're gonna say import pandas as pd pd.read csv optimization data slash group optimizations slash 2023 12/14. Oh, did I update the date on here? 2023 12/14. Very good. All right. 2023 12/14 8 slash results dot csv. And let's change one more thing. df dot set index. We want the index to be year. Then it will look nicer. Okay. Now let's put it in our PowerPoint. Okay, so this is the triangle region optimization. Significant improvement using percent returns instead of profit on the triangle method. So that gave us positive returns every year except 2. Um, and while we're here, let's just run that again. Um, and the only difference we're going to make is num years to train on. Um, so let's test training years. Test training years. All right, test training years is equal to 1. Now perform optimization analysis is off. Perform optimizations, num years to train on is equal to year. Region type is equal to triangle. Test years. So test years, does it default to all years? Yep. Okay, so this should be good. Um, perform option A equals pd.read CSV test all results. Um, well, I mean, yeah, we will have them in here. So, um, in perform optimizations, we can specify folder location. So optimization data slash group optimizations. So yeah, let's just make it in here. So perform optimizations, then let's say here, folder location is equal to optimization data slash um, training years test. And then slash year. Training years test slash year. Okay. Now, if not os.path.exists, optimization data slash training years test, training years test. So if this path does not exist, we're gonna say go ahead and make that directory. Gotta remember to pull the chat up so I don't miss out on anything. Oh hey, good thing I looked at it. Javon Innocent, this is my first time here. Do you have a GitHub with all this code and documentation? Sorry, I haven't been able to watch past videos yet. Yeah, I think I put the GitHub in the description for the stream. Yep, just go to the stream description. It says get data here. I haven't been updating the code. That's because here's my code folder. It's a little bit of a mess right now. Um, But my plan is to update it. I haven't updated anything though. Here's all I have in the repository right now. But you can get the data in the repository, which is the big thing. If you I also linked that video I made. The data was for sale for $264. Oh, here it is. It was for sale for $264, and I scraped it all and put it in here. Um, so you could get the data file, and you could get the files to scrape and clean the data, but I haven't added any of the analysis yet. Um, I am planning to add the analysis, but I just have to clean up the code. It's messy, so um, maybe today, maybe definitely by the end of this week. It's already Thursday, so um, hope that makes sense if you're still watching. We'll pin your comment because it's the only one. All right, then. So you could, if you're listening, you can look at the link in the live stream description, or I just sent it in the chat. Um, so, where were we? So we want to make the directory. So if this directory doesn't exist, we want to make it. Okay. And then in here, let's copy this. And then we're also going to say that if this one doesn't yet exist, we want to make it as well. Okay. So if not os dot path dot exists. So if we don't have that, then go ahead and make the directory. Um, okay, so this should work for storing the data. Let's go see. Analysis1.py, are we doing test training years? Yep. All right, that looks good. Let's go check to make sure everything's storing the right way. Optimization data, group optimizations. No, we want training years test. Here's the first one. It's a little bit confusing, but that's fine. Training years test, 1, then the date, then 0, then these. So what did I put as the path? Oh, if not, so it's gonna rewrite each folder for each year. So for year and years, if not os.path exists, folder location equals year. Yeah, this is pretty confusing. So training years to test slash training years to test. If that doesn't work, then make training years to test slash year. Oh, okay. So that is when we're testing 1 year. Okay, good, good, good. So this looks good. So training years to test 1, and then I don't know why that's in 1, but whatever. That must be, yeah, that's because we're testing 1 year. And then we have the date. Then we have the 0th thing in there. So that won't really do anything for us, but we can go look at the results. And yeah, this doesn't do as well, but that's not so surprising. Um, okay. Now, so we've done all that. We're testing the number of years to train on. We need to do the optimization for each type of region using percent returns. Okay. Let's go add a checklist. So the first thing to do we did, or we're doing, is the triangle region. Next we want to do rectangle. Rectangle. And then we want to do modified triangle. Is it modified triangle? What do we call this? Modified, yeah, modified triangle, hybrid, and the free circle method. And we're still trying to add in the free circle method. So get region, if region type is free circle, we have the center point, we have the radius, and how do we do this again? Circle, okay. So we're gonna say that. Now region points is equal to point of region params of h, comma, so hk is our center point. Point that, and then we do a buffer around it. So get the point, then dot buffer, whatever the radius is. All right. And we have that. Now we can go test if the plotting works. That's the first thing to do, is test region plot to make sure that it's plotting the right thing. So let's take that off for now. Turn on test region plot. That's still running, so we could open a new terminal. Okay. Now let's go to our directory. Total analysis. So yeah, we just want to run this file again. Python 3 analysis1.py. Okay, that gives the triangular region. We want to try the free circle now. Test region plot. Region type is equal to free circle. And then here we can say region params are equal to h, just make it 200, so the center could be at 200 minus 200 minus 200 minus 300. No, h is 200, k is minus 300, and then radius is 100. Then we plot region params and region type. All right, now let's go see if that works. Nice. Okay, so now we can, that doesn't look like a circle though, that looks like an ellipse. That is an ellipse. Okay. Why is that an ellipse? HKs, I need to join a gun club. Oh, that's a circle. First, we create a simple point with a radius of 1. Next, we take the circle and pass it into the... Yeah, what's... dot buffer? 100... So it goes from X... Let's see, just down here. All right, minus 65 and a half. So minus 65 and a half to 351, so about 400. Now this goes from minus 480 to minus 58. Yeah, so the scales are about the same. Why is that an ellipse? Hmm. Let's go look at where we defined it. Free circle, HK and R, point HK dot buffer radius. That just doesn't make any sense. How is that a circle with radius 1? Alright, so let's change the parameters to just be 1. Should be a circle at 0, 0, the unit circle. Let's make the unit circle. Alright, so the circle is going to be at 0, 0. Yeah, might as well make the radius 100 so we don't have to zoom in as much. And again, it's an ellipse. I think it's an ellipse. Oh, you know what? That might be a circle. I think I'm tripping. That is definitely the right thing. So let's go back and try to do the last one again. Save it, and are we going to save our circle if the aspect ratio is right? That's the question. I think so. So stretch that down a little bit. And our circle is back. Nice. Okay, so now we're drawing a random circle. Now let's optimize and see if it finds something interesting to do. Test optimization is equal to true. So now test optimization. Yeah, that's all we want to do now. And then the region type should be a free circle. So we want to see how the optimization does making a free circle. And then up here, the default, nice, is single optimizations. So then let's just take off our plotting test and let's turn on our optimization test. Now let's go run it and see what it does. Oh. Um. Uh. I'm gonna make a directory. Just gonna make that directory. Optimization data slash single optimizations. All right. Now that should run. Bounds referenced before assignment. That's right, I forgot. The other, so we have to change that stuff up top, and then we also have to change bounds, which should be added into the dictionary. In fact, I'm going to write that as a to-do on the Trello. All right, I'm going to add that there. Take bounds definition out of optimize line location and put it into the regions dictionary. And that is high priority because I want to make adding new regions as easy as possible. Okay, so now otherwise, if region type is equal to free circle bounds, so it should be free to wander. The center should be able to wander between plus and minus 1,000 for x and y, and then the radius should be able to wander between 0 and say 1,000. And then we're gonna have to use a big pop size probably, but let's start with pop size of 10. And we're testing the optimization. Okay, now let's run it. Cool. So it's working. Now this, like I said, this is going to take a long time to run, I think. Um, let's go out and see if we could find. So I think one, yeah, that would be the one we're running. It's doing those seasons and it's doing free circle. So it's optimizing. I guess those are the seasons it's optimizing for. And it's optimizing to get a free circle. Okay. Oh, no. What if we go look at this CSV? Wonder how the values are doing. So it's only around 283. 351. Okay, we could check it when it's around 1,000. So, um, what else do we want to do? Oh, we wrote in the free circle. Now let's write in the free triangle. Okay, we've written that part. Okay. Free triangle is a triangle whose vertices are free to travel. Um, yeah, basically that, I guess. Triangle whose vertices are free parameters. Okay, so 6 total free parameters. Okay, then free triangle, get region, elif, 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 elif. Okay, here, let's do another elif. Elif elif region type is equal to free triangle. Let's say pass, and let's go check on how our optimization is doing. Is it still going? Uh-oh, it looks like it's just trying to, ooh, yeah, it's trying to make net return 0. So it's having trouble finding a region that works. It's just trying to, oh, never mind. I'm returning the negative of what the actual returns are. So this is trying to get a positive return. That's actually nice. So it's either getting a positive return or 0. I wonder what it's going to optimize to. So let's see. It says, so it's using a radius with a huge circle. This might not be able to converge. It might just not find anything that works. We might be using too broad of a parameter space. I mean, 1,300 evaluations is a ton. We could go try to look at this in Excel. Okay, so H, at least, yeah, it looks like H is kind of converging. K isn't really finding anything. So H is where it goes on the x-axis. So yeah, it is finding it needs to be somewhere positive on the x-axis. That's good. That's what we want it to find. So it might just be going really slow because there's still not much of a trend for K, but it looks like it's trying to make it higher, which is weird. The radius is all over the place as well. Probably to get the radius to start working, we need a center point. We need to at least find like a range of center points. Now we're at 2100. Yeah, this is still bouncing all over the place. It's not finding anything. Delimited by a comma. Oh, well, yeah, I think it might just be taking a really long time because we see H is definitely converging towards a value here. And probably we need H to start to converge before we could get anything else to start to converge, because H is where it is horizontally. So this very well just could take forever. Um, right, and this is training on the circle. So free triangle isn't going to work, I don't think. Um, Free triangle region points will be easy to define though. Region points is equal to region params of, huh, region params of, that's right, P1X, P1Y, yada yada yada. Okay, so P1X, region points, okay, so point 1x, and then region params of point 1y. And we could just make three little tuples. P1x, so below it will be the same thing, except P2, x and y. And then the last one will be the same thing, except 3 instead of 1 or 2. Cool. That was easy. And then we need to add in bounds. So here we say elif region type is equal to free triangle. Whoa, it finished. All right, let's say pass, and then let's go look at the data. Oh, yeah, I forgot. Actually, let's just look at the data in here. So then we could say data is equal to pd.read csv. This is in optimization data slash single optimizations slash 2023 1214 slash 1.csv. All right, now d dot h dot plot from matplotlib import pyplot as plt plt.show. Okay, so h converged on a nice positive value. All right, now let's do h. Now instead of h, we want to do k dot scatter plot. Okay, k converged to a positive value. So, damn it. Now let's look at profit. Show the plot. So this is probably centering on a region where it was either taking one bet or no bets. Yes, I knew it. Okay, so the problem with the circle optimization is it finds a region that takes no bets or one bet. Okay, so we need a better way to look. Oh, could just put that right into the PowerPoint, duh. Okay, add a slide. Circular region. Since we are optimizing for percent return, the circular region finds a place that gets that places no or one bet. This way, um, percent return will either be positive or 0 but never goes negative. So we need better ways to optimize, and we might need some new algorithms to look at other than differential evolution. I like differential evolution because it's so general, but there are some drawbacks to it. Um, how could we put this in here? Make this look nice. All right, so circular region. All right. So that's what the circular region does. Maybe if we could optimize on less data. Um, so if we just optimize for a single year, what's it look like? Um, so test optimization, test region plot, test region profit, test optimization, optimize line location, 2007 to 2017. Free circle. So instead of that, we're gonna optimize for 2021 to 2022. 2022. All right, so let's just do it on 2021 data and see what that does. You know what? We want to look at that. No, let's say percent return, uh, percent return versus eval number. Okay, and that should clearly show what happened with the over the course of the optimization. Put that into the PowerPoint. All right. So that's the problem with the circular region. Now let's run it again, and we're only going to train on 1 year. Test optimization. Yep. So now let's only train on 1 year to see what we get. Maybe with less data, it won't have so much trouble avoiding the losses there. Now what were we going to do, this is still running, so let's go check on that, see how that's doing. So group optimizations, no, training years test. Okay, so there's a new one of these for each number of years to go back. The one that's 10 years. Oh, so it's literally finishing up the last one right now. Okay. For year in num years. Alright, so this is training on the last 1 year. Not so great. This is training on the last 2 years. Wow, better only, oh, two negative years, but that's pretty good. Alright, now if we're training on the previous 3 years, less successful, we get these 3 negative years, 14, 17, and 18. So that's on 3 previous years. Training on 4 previous years. Still get some negatives in there. Okay, so that's 4 previous years. It's not looking like any of this will really work, but let's see. Yep, again, negative years in 18 and 20. Okay, so this was going back 5 years, going back 6 years. What's it look like? That's pretty good. Only one negative year. The only negative year was 2018, but then in 20 and 21 we wouldn't have placed any bets. So that's not so great. 7. Whoa. Okay, that's positive. So if we train on the previous 7 years, we don't get any negative returns. Now that's kind of, I don't really know what to make of that. Because 7 years is a random number. And if we're going to say, hey, this basically, if we train on 1 year, 2 year, 3 years, 4 years, all the way up to 11 years, none of it works except only using 7 years of previous data works. If that's what happens, then we don't, I'm not sure that we have a strategy. Where do we put this in? Does limiting number of training data? Oh, okay. So how many seasons back should we look? Using triangle method. Here are the results. So, let's say Python 3 for year in np.arange from 1 to 11 dot to list file loc is equal to f of optimization data slash, put that back there, optimization data slash training years test slash training years test slash 7 slash training years test slash year. Import numpy as np. Okay, so that's right. Now we have our file location. Data is equal to pd.read csv of file loc, then data, okay, just plt.plot, plt.plot data dot year, comma, data dot percent return, and then the label should be years. Yeah. All right, now we're going to do import pandas as pd, and then from matplotlib, import pyplot as plt. Now we could go do our loop again. Plot it. Damn it. All right, file loc, then data is read file loc. Then we're going to plot. All right, and then let's label it. Next label is season. plt.ylabel is percent return. plt.title is testing how many seasons to look back with triangle method. Why not? All right, so let's go plot that again. plt.axhline at 0. and we could show it. Okay, so damn it, I forgot the legend again. Okay, so I guess it regularly falls in that problem. Regularly runs into that issue in 2018. 2018 was a hard season to predict. Now that can't be a coincidence. 2018 was a hard season to predict with this method, and it was the first year of sports betting. There's no way that's a coincidence. That has to be related. Nice. Okay, well now we still need the title for this plot. All right. Then all methods are back to winning by 2021. Okay. Now this we could put into our PowerPoint. Okay, so we notice there's the one season where it never goes negative. So it never loses. Now let's plot the cumulative returns. So probably, how do I get cumulative returns? I think cumulative sum. Pandas get cumulative returns. Um, so yeah, so we started with $10. Let's try to plot what would happen if we started each strategy with $10. So for year in np.a range, file location. Now we have data. All right. Now seasons is equal to a blank list, and then value is equal to a blank list. And then bet amount is equal to 10, and then we're going to say percent return. Oh, but we don't know how many bets we placed, so that wouldn't help us. Okay, well that's fine. We could just leave it as percent return for now. So, is there anything else running right now? No. So what we want to do is, let's go look at the Trello board. So we want to do this analysis on all region types. I could do this not on live stream because that's not very interesting. Look into doing a free ellipse region, take bounds definition out of optimized line location. Okay, so there's nothing left to do today. I'll do this before I start the next live stream. Then that, since the circle doesn't perform really well, this is going to become low priority. And take off the high priority label. And I'm going to write a comment. Nope, here. Low priority because circle. Because the simpler circle method does not work yet. Okay, so next time we're going to have results for results that look like this, not only for the triangle method, but for all methods. And then we're going to, before the next live stream, I'm going to test, do basically this test for the different methods. And then from there, we're going to keep trying to build a model that consistently returns money for every season. So thanks for watching.